So, smooth muscle. Smooth muscle, to the extent that we're going to cover it, we're not going to go into a whole lot of detail here. It's really just to compare and contrast it with skeletal muscle. And then in A&P2, you're going to get more into the function of smooth muscle and how it works. But it's good to get this sort of background, this basic information on how smooth muscle works, because it's completely different from the way skeletal muscle works, because we don't have sarcomeres at all. Instead, we have our actin and our myosin just kind of scattered around. So I'm drawing some little bundles of actin here. So that's our actin bundles just all throughout the cell of smooth muscle, and it's not F-actin like we saw in skeletal muscle. It's something called alpha-actin. So it's going to have a completely different structure, completely different setup to our F-actin that was made up of a bunch of little G-actin balls or beads or globular proteins, however you want to think of it. It's just going to be strands of this actin. Now there are still places for myosin heads to bind, so we need to put some myosin here. And I'm just going to draw a couple. So the tail and the head, I'll just draw that. Keep it simple. And that's also just scattered around. But what we need to think about here is what is keeping it from contracting during the rest phase. So why isn't the myosin head just binding to the actin and pivoting if we don't have troponin and tropomyosin and all the G-actin and we don't have all that? So the answer lies in the structure of the myosin itself. So here's the myosin tail, here's the myosin head, and wrapped around the neck, essentially, of that myosin, so right there, right at where the head is joining into the tail, there's something called a myosin light chain. And that myosin light chain acts as sort of a lock on the myosin head. It keeps it from pivoting. So I'm going to stick my hand in here. Excuse the manicure. I haven't been able to get a manicure for a while, so it looks terrible, but you get the idea. So this will be my myosin head, and then my wrist will be where the myosin tail begins. And the myosin light chain is going to be wrapped around right there, that neck there. It's going to keep the myosin head from pivoting. So the myosin head wants to bind to the actin, it can't. So what we need to do in order to have an actual contraction is to release the myosin light chain, activate it so that it opens up, and then the myosin head can bind and pivot. So that's what the action potential is going to accomplish. So when we have an action potential in smooth muscle, we're going to open something called L-type calcium channels. These calcium channels are obviously for calcium to move across the cell membrane. So right there. L-type means that they are long-lasting. They are called slow because they are long-lasting. When they open, they stay open for a relatively long period of time, and it takes them a relatively long period of time to close. And they're also voltage-gated, which we haven't gotten to what voltage-gated means. That's for our neuro section. But essentially, just in a nutshell, it means that there is a certain electrical activity that is required to open these up. And when that happens, we open them up, calcium can move through them and go into the cytoplasm. So now we have calcium out in the cytoplasm. That leads us to our next step, which is that calcium is going to bind to an enzyme called calmodulin. And calmodulin is going to be activated by calcium in this way, and it will then activate another enzyme, which is called the myosin light chain kinase. I'm going to run out of room, aren't I? Myosin light chain kinase. So what the myosin light chain kinase does is it goes to the myosin light chain and it activates it. It pulls it away. So if we go back to my little hand here with the myosin light chain, the calcium came in, it bound to calmodulin, the calmodulin was activated, and then in turn it activates the myosin light chain kinase, which unlocks the myosin light chain, and the myosin head can bind and pivot. Now, also listed on the slides are some other characteristics about smooth muscle that are different from skeletal muscle. Probably the most important part is that it is innervated by the autonomic nervous system, which is the part of the nervous system that innervates not just smooth muscle, but also glands, cardiac muscle, things like that, things that you don't have conscious control over. Skeletal muscle, on the other hand, is activated by something called the somatic nervous system, which is under your conscious control. So anytime you have something autonomic, it's something that you cannot affect consciously. When it's somatic, it's something that you can affect consciously. And we're going to come back to that when we get into the nervous system. We're going to see a lot about this stuff, but just starting to think about it. Okay, so that is smooth muscle. Our next video will be doing the same thing with cardiac muscle, comparing and contrasting cardiac muscle.